from India, some past earthquake, some now.
As per your choice, whether sugar.
Now, I would like to, what is earthquake? Before taking my topic, as we all know that how it happened earthquake, and we know that earth is round. Earth is round. Earth is having four layers: inner core, outer core, mantle, and crust. So then we have this after we have here continental drift. This is for 425 years, 135 years, because our continent was it was not like this before. Now we have the Indian continent here. So millions years ago, India was with ocean and continent. So then now we are having at present we are having today India is the last part, and this is the as we know that we have different tectonic plates. Different tectonic plates, around 12 major plates are here, and many small plates are also here. And we are Eurasian plate and the Indian plates between them here. Then, as we know that tectonic plates, because of this plate movement, earthquake very frequently happen. And then we are this divided into three tectonic plates. There is convergent, which comes together. Two plates come together, and then divergent plates go apart, and then transport plates go apart. They go their front and back. So these things I will not explain more. Only just for remembering the earthquake, just I am putting these slides. So because there are so many slides, so I am going to run it quickly. So as you know that plate tectonic, and this picture shows that the convergent plate, Himalayan plate goes up and Indian plate goes down. Because of that sometimes earthquake also happens. And these 12 to 20 mm every year it moves. So let's see. So after the earthquake, what happens is that here I am showing the two earthquakes where after the earthquake the trade changes. Then liquefaction is there. So it happens the liquefaction, it happens the breeze damage, it happens so many things. Next. So plate tectonic, as it's like before we have taken the continental maps, and now Indian map. 30 million years ago, 100 million years ago, and then 55 million years ago. So Indian map changes, as we all know, because we all are maximum engineers. We studied about the seismologists, we are architects, we are geologists. We all know about this map. Indian map changes, but slowly. Then here the plate tectonic, which I told before also, plate tectonic is having convergence, divergence, and transform. Then some danger levels of about when we come to the earthquake, danger levels are there. Danger level minor, moderate, and And seismograph records these things. We have seismograph station at Manipur University, at Chimayong, and the big one is at Shillong. So seismograph records all the earthquakes. And so Kobe earthquake 1995 and January 17, the effects of earthquake it is. This is the Loma Prieta earthquake 1989. Loma Prieta earthquake was in the northern California, and then the Loma means dark and Prieta means hill. It is a Spanish. Sorry? So now I am saying that seismic zones in India, as we all know that seismic zones of the geological survey of India 1935 started the seismic zones in India with 3 zones, and then again review to it was up to 1959 and review of 1970, and then it became the seismic zone to 6, 0 to Roman 6. Then again changes up to 1972 and changes all give to IS 1893 2002 become the zone 5. That is where is the highest, zone 5 is the highest, minor, slight, moderate, they give this vulnerability, that seismic zone. Then it comes to the review, it reviews after every year, and the India became alarmed after the Bush earthquake 2001, 26 January. So many buildings damaged, life loss. After that, again this IS 1893 was reviewed 2016 1893, and India in that all the provisions of these load calculations are given. Then base year calculation has been changed. The important factors have been changed, response reduction factor has been changed, zone factor has been changed. So, in that time, till now we are having in zone 5. In zone 5 here, and then this 2023 which I am showing, it is a draft. It's a draft map of Indian seismic zone. It is not finalized. Here comes zone 6, up to zone 6. So 1 and 2 combined together, 2, 3, 4, 5, 6. So we may be in zone 6, most probably. It is the region, it is brought by the scientists. They have brought. So we are in zone 6. We are in zone 5. So like that, so what we have to do is that we have to take care of our buildings, we have to take care of our bridges, we have to take care of while designing, and then so this is the vulnerability, seismic vulnerability of India. Seismic vulnerability of India, it is also in the report 1893 2016. 2016 we are using right now. 2023 is not still open. So in the seismic zone areas they have given. So issues of existing buildings. What are the issues we are facing now? Is that we are having this when we are constructing, when we are doing this giving the RCC structure, when we give still and this spacing, sometimes it is given without seeing the code. We have to use code always 1993 13920 2016. 13920 is it is for the time detailing, and 15988 is for RCC retrofitting and so and so. So we have to the flight performance and the visual performance. Their horizontal movement of group is showing horizontal. When there is a suppose when there is a static and dynamic, what we have to calculate. First we have to calculate static calculation. We calculate the single degrees of the freedoms. This static compression we use the base here we calculate. We teach to the students how to solve the base here. Then dynamics of structure comes. There are single degrees of freedom and multi degrees of freedom we teach to the students. So where the type of moment is how it is brittle collapse is how it is because the stiffness when the earthquake ground motion comes the stiffness changes and then the displacement here due to that if the mass is very heavy and the stiffness is small then the displacement changes. So according to we have to think that which type of structure we are analyzing, we are designing. We have to think before that. And the materials, what we are using, grade of steel, grade of concrete, and which type of building we are using, which type of structure, that it is RCC or it is composite, it is steel and RCC, it is a bamboo structure, or it is a wooden structure, or it is only steel structure, or it is only masonry, it is only like that. So depends upon the material, we have to design and analyze and design properly. So here some images we are seeing the columns showing the buckling, the pin column joints, the scale failure is here. So like this, we have to always consider all these points. Here, some earthquakes mostly the buildings were soft-story. Right, sir? Buildings were soft-story and the buildings not properly designed. And other earthquake, notice earthquake, and the soft-story buildings always have problem. So if you want to avoid, then we have to keep shear walls. If because the parking system is there, this and that, this we have to design properly. Then, so Manipur became very much alert after 2016, 4th January 2016 earthquake. We the engineers, civil engineers, architect, owner, we have to be a triangle. Civil engineer, architect, owner, we have to make a triangle. We have to discuss which type of building we are going to design, which type of building we are going to construct. So, in this 2016 Manipur earthquake early morning, it happened, it was in 6.7 local magnitude. Magnitude, we have different scales, magnitude. Magnitude gives the size of the earthquake. Local magnitude, moment magnitude, body weight magnitude, surface weight magnitude, different scale, magnitude scale is there. And the intensity gives the intensity is different place to place. And magnitude is only one. So local magnitude ML 6.7 it was. And many houses damaged and destroyed at time. Collapse. So this was the BSNL office. During that time, some of our students and myself, we visited places and we looked where it is damaging, what it happened is we collect the datas. What we collect the datas of Professor Arya's then format is there. According to that, we collect the datas. We visited the BSNL Polytechnic, and different other places. And also there was a team of I.E.I. engineers from PWD, member from MIT, member from I.E.I. We made a team, emergency team. We gave emergency phone numbers to the public because public they don't know if something happened with their staircase, something happened with their wall, something happened with their slab. They do not know whom they have to ask. So immediately I.E.I. joined together with engineers, architects. We gave helpline, visited different places. And if it can be done with a small repairing, we told to them immediately. If it has to be another measurement and another retrofitting, we told to them. Like this, it happened during that time. So from that time, our students MIT started the research work, and students they were very much happy and excited, and they were worried about it because they were as engineering students, so they wanted to help. So they did many projects in this regard. They took projects of this government polytechnic. It will be coming afterwards also, and they took projects because the lifeline buildings are very important for us. For example, hospital, school, college, or lifeline buildings. This should be earthquake resistance design. Earthquake proof buildings we cannot construct because it is very expensive. Earthquake proof building only in the Indonesia they have made one big building with a capacity of 5,000, but very huge amount, 40 to 50 million dollars they spend for that. That we cannot do here. We can do only earthquake resistant design. And we have to search the vulnerability of buildings. So these were Manipur earthquake 2016 different buildings we visited, and the difference they are only the plaster or only the staircase and only some settlement, different things we have found. And this was the building soil failure, Islam Park. Because we the students, rushed to that different places, we searched and find out the damaged building. And we gave information to the owners or to the government, but I don't know so far government is taking up these steps. And BSNL, they did very small repairing and they finished it. So their life is very dangerous. So this is the I.E.I. hill, where thousands of imams, means mother, are coming every day and selling the clothes, vegetables. So it happened. Luckily on that day it was morning, so no one was injured. But I.E.I. hill, 3 I.E.I. hill, one was nothing happened. 2 were very much damaged. So the I.E.I. hill, the problem of I.E.I. hill was the column was round column, and the tiles were not accordingly cut. And inside the column there were pipe. Big pipes were there. And staircase, there are so many damages, staircase, beam, column, so many damages were there. So like this is a pipe, and this is the pipe when we studied about the round column, this stirrup should be round, the spiral, right sir? Spiral, it should be spiral, but there is no spiral. And the joints are not tight. I think because of that. And the concrete was not good. Grade of concrete was not M20 or even M59. it happened. The material also very important. Design also very important. Construction time is also very important. So in our market it was the things. It happened in Kalam drawing. So afterwards, let's see next slide. Poor maintenance, material failures. Whenever we construct a building, a structure, bridge or building, we never do maintenance. Maintenance policy is very important. We never do it until unless it becomes the cracks or these things. Maintenance policy should be there. In my PhD work, I did, it was okay. I completed my PhD in 1990. My work was repair and maintenance of steel structure based on the theory of reliability. With the maintenance policy, we can find out which year we have to do maintenance. Minor repairing, major repairing, all this we have to think. Because the money, if we don't do in time, money will be losing, life will be losing, so many things. So these are the Manipur earthquake, Khangam Bazar and Dulalel. We visited to Khangam Bazar, Khangam Bazar, Dulalel, I.E.I school, and Dulalel, I think it was 4-story building collapse. What happened, I don't know. In that 4th January 2016 earthquake with a magnitude of 6.7 and then so there now it's different places, buildings are there. And so far we have seen some few structures retrofitting was done in I.E.I school, in I.E.I, it was done by PWD engineers. We are grateful to the PWD engineers. They have done a lot of work. We, the MIT students and teachers, we went to visit only. We collected some datas. I went with my students. We have seen how the retrofitting was done. So, it is very near. As all you know, our polytechnic controller, our polytechnic principal is here with us. Why, sir? Why students are not shouting? Why you are not doing repairing or reconstruction? Some small repairing is done there. We have seen there the steel columns with the corrosion steel columns are standing there inside. And the students are studying, polytechnic students, thousands of students are studying there. But in the next earthquake comes, what will happen with the life of the students and teachers? Our government is not taking out. This is the important building. But really, I am very much afraid of this. In case something happens between this, we do not know earthquake. We cannot predict earthquake. But we are in zone 5. We were in the plate belt area, the earthquake belt area. So now I want to request, taking the chance of our Sir Nando's representative here, so I am taking this opportunity that please be careful. We cannot run away from here. We have to teach the students. We have to take care of our students. So please be careful. So tomorrow but not now anymore. These things will happen. So many things happen in this. Few of them we have brought here. 2016 earthquake, Manipur earthquake. It was on 4th January. And this was the polytechnic. Child, you will be seeing that on the top of the polytechnic there is no head. Head was this one, the globe. Globe was the head. It removed after the earthquake. So what happened? Huge corrosion still. Still problem is with corrosion and fire. So what will be the future of polytechnic students and faculties? What will do? This I am giving this floor. So please come. And it was collapse story in Dulan, 3 or 4 story collapse. And now they must have constructed a new house and a collapse building at Kaisampan. So after seeing this, really we are very much afraid. We the engineers also very much afraid. And what will happen with the laymen? So we have as part of IF 13935/1993, some definitions were there. Repairing definition, retrofitting definition, strengthening definition were given by the scientists. Newman, he had given the this definition. There are so many other definitions are also there. So, the need of seismic retrofitting of building arises, earthquake damage buildings, earthquake vulnerable buildings which have not yet experienced. So these two are main things. Earthquake damage building, earthquake did not be the damage which we have to be vulnerability assessment. So next. The problem faced by a structural engineer in retrofitting earthquake or structural engineer, civil engineer, what the problems are facing? The facing the lack of standards for method of retrofitting. This is the main cause. And the effective of retrofitting techniques, there is considerable dirt experience that we are having now. Because now it is very much advanced. In other parts of India, they are using many devices. But we cannot do reconstruction with negating, with the of course we have done in the Imam market. But this cannot be for the story buildings. Some advanced techniques we need to know, and those things techniques also should be available here. Our techniques are not updated. We are still lagging behind. So many existing development seismic strength requirement, because we are not using our buildings are non-engineered buildings. Mostly only mason and owner. Owners do not want to spend money. They say it's not necessary. So they don't know who is civil engineer, they don't know who is architect, they don't know. Even sometimes only those who knows they hire only. They say that please design my building this there. And then we the engineers, we have to know all these codes. For loads, we have to calculate different loads. Dead load, light load, seismic load, different, it depends upon which area. Snow load, all this depends upon the area, temperature load, all this, like the code is updating. Bureau of Indian Standard is working hard to update the code. Right now, we are using 13920, Part 1, 2016. That means coming a draft up to 23. And 13920 2016, the kind detailing 1893, building provision part 1. So all these things we have to check. Now without all these things, if someone is designed, then the building will be having problem. So additional instructions we have to 13935 2009, 1893 2016, 13920 2016. So all these codes are very important. So structural performance level. What is the structural performance? That is immediate occupancy and life safety plus prevention. According to this, we have the collapse prevention performance stage just preceding to collapse. The structure suffered extensive damage to the excellent and the non-structural elements. We should consider our structural elements and also non-structural elements also we have to consider. So again I am coming to the vulnerability assessment. Vulnerability assessment is very important. But the I.E.I, Vulnerability I.E.I of India has given many reports about the vulnerability, which area is vulnerable, which is vulnerable. That is also very important. Reports for all over India. Even Manipur reports are also there. Seismic vulnerability spaces is assessment. There are three types: repeat visual screening, simplified vulnerability assessment, and detailed vulnerability assessment. And simplified vulnerability assessment, according to these many students, they have done research work in this field. This is just visual screening, and first we use in this that Professor Arya Foreman, when building was constructed, which type of building it is, and then which type of it is a irregular building or regular building, it is the size of the column. According to that, we decide this building is vulnerable or not. If it is vulnerable, we come to the next step. Next step is this simplified vulnerability assessment. This requires immediate engineering analysis based on information visual observation. When we go to visual inspection, based on that, if the owner or the proprietor is having drawings for the previous building, it is okay to analyze. The building column was how big, size, beam, slab, all that we can analyze and design newly. But if we don't have what to do, if we don't have because some people they don't just throw away the drawing, they don't understand. They just threw away because their building is constructed. So we the engineers, we have to throw again. We have to take the measurements, we have to throw again. So like the detailed vulnerability assessment requires detailed computer analysis and the use of different equipments. Computer analysis. We have to do the computer analysis we are using nowadays is very much advanced. We are using, before we used to draw in a paper with hand. Now we have AutoCAD for doing, we have softwares, Stable, E-Tape, Shape, Resist, so many things for architecture, for civil engineers. So this is a picture of my MTech ex-student. Now he is working and also doing research and practicing. He visited to one place because the client requested him to check his building. So there, rebound hammer test we did, ultrasonic pulse velocity we did, and then rebar locator we use. So this we have some equipments in our lab, but not so many. We have some few equipments. And now technical colleges are here, NIT, MIT, MTU, and different departments. We have to purchase new equipments. So I'm not explaining much because there is no time. So I just want to tell that, and this this rebound hammer test we have to check for the concrete level. It was constructed with the M15 or it was constructed in construction, it was M20. Now how much we are getting, we have to check. According to that that we have to decide. And this report is located just like a X-ray machine. When we take our body X-ray, we see all the bones inside. Like that, we could building, so we can see all the bones. Then we can see which type of cells are used. So, retrofitting techniques are here. I think I need to must explain because already have already explained global and local. So we already have seen this. So please see it. So anyway, here what? I think you must have seen somewhere. I think the shear wall. If the building is not much having the strength is less, so we use a shear wall. Or if there is a multi-story buildings, we use the shear wall also. And then base isolation system. Base isolation system is a very advanced technique, but still now this base isolation we are not using much. But base isolation and other devices, IITs, they are doing very much. Our ex-student, our MIT ex-student, his name is Roman Babu. He did his PhD in IIT Delhi. He did his research work in this field. And then RCC decaying. RCC decaying was done here. Where? In Imam Market. Then there's a hotel. Before it was just building. So after the earthquake, they did retrofitting. Retrofitting was done by he is no more now, our active I.E.I. member, PWD engineer, Sir Narendra. He was having very excellent knowledge. He was sharing to us all of these things. There is no more because of COVID. And this is the strengthening of foundation. It was done in the market. And then retrofitting started with local modification. Columns, big column drawing, plain column drawing. Local modification we can have. Accordingly, we have to do analysis, we have to do design first, then accordingly we have to take up these steps. The retrofitting strategies are here. Existing structure here, the blue arrow, group displacement and base here. When we calculate the base here, and when we calculate the group displacement, we found that existing structures are coming down the arrow. And then original target, even it was not reaching. And then rehabilitated structures, it is coming out. And vulnerable elements, we have to find out. And global modification, it comes like this. Original and the rehab target replacement, the rehabilitated structures, existing structures. So, how to select retrofitting method? When we say a building, we cannot do immediately, oh, it is needed retrofitting. No, we can't say. How to select it? What type of deficiency is in that structure? Fractural, shear, axial, combination of above deficiencies. We have to select. Then, which method, local or global? And with the different types of this analysis, there are different types of analysis. Focus analysis and the dynasty analysis, different software we can use. Retrofitting strategy is a damper. Actually, is our ex-student Rahman Babu. He got in Australia. He got award for best paper. he introduced one new device for base isolation. So types of energy dissipation systems we have different. Some case studies. So as I told my friends